Hello friends, welcome back to our channel. So in today's video, we'll be looking at the current status of Western disturbance and what we can expect in next 2-3 days. So first of all, let's analyze the current satellite image, where we can see that most of the intense or deep clouds are limited to the northern regions of India, mostly located over the foothills of Himalayas, where the moisture fluxes are converging. We have decent amount of clouds over the Punjab region, which is the squall line, triggering a lot of convection. Over other regions, including uh, Haryana, Delhi NCR, and Western UP, isolated rainfall activities are visible. But as far as heavy rainfall is concerned, it is limited to Uttarakhand, Himachal, and Jammu and Kashmir. Now, let's look at the satellite image or satellite animation from the visible spectrum for last 6 hours, which will give us the clear idea as to how the system has evolved. It is not working. So let me see what we can do. So let me do it manually. So see, most of the clouds are forming over the southern Rajasthan and actually ascending up towards the Himalayan region. And this clearly suggests that the most of the moisture for this western disturbance are coming from the Arabian Sea. Uh, Now, the interesting point here I would like to put emphasis on is these streamlines which are coming from these streamline type streams of clouds which are radiating from the Himalayan region. So I hope you can see that. So here we have scattered or more heterogeneous type of cloud from just uh, this is I mean after some imaginary line, these clouds are taking form of streamlines. Now, why this is happening? This is very interesting phenomena. To understand that, let's analyze the wind. If you see the surface wind, you don't see anything. Yeah, the surface wind. Now, let's go to around 600 hectopascal, which is around 4.2 kilometer height. If you look at, you will see that intense, these are the colors are wind, and arrows are having their obvious meaning. So these winds are coming from the Arabian Sea, and just as soon as they reach the Himalayan region, you will see there is a instant decrement of the wind. So currently, so let's see here, the wind speeds are around 88 kilometer per hour. You just move few kilometer after that, the winds are just 13 kilometer. Why this is happening? Because these are the Himalayan range. Whenever the winds are colliding with it, they can't go further back. So this is behaving like a blocking region. Now, if they cannot go ahead, where they will go? From the continuity, they have to go somewhere. They cannot go down. They will go up. So there will be intense ascending motion over along this line of convergence. So there is a convergence. The wind is coming and not going. So more wind are coming, less wind are going out from along this line. It means there is a convergence zone starting from this region up to Jammu and Kashmir. And as soon as these winds goes up, they have moisture. The moisture is also coming from the Arabian Sea, and this moisture will also go up with the winds. And we all know that as moisture goes up, it cools down because the temperature is related usually are less in the upper levels compared to the ground. That's why the hill stations are mostly cold. So as soon as this air lifts up, it gets cold. And once it gets cold, it reaches to saturation point, or perhaps the dew point. You can call it dew point. So as soon as it rises at a certain height, it reaches to a dew point, and at the dew point, the cloud formation happens. And once there is a cloud formation, and there is continuous moisture supply, they will start raining because they will get super saturated. And that is why we are seeing the most of the clouds along this line. And just look, just keep bear with me, and just I am just overlapping the satellite here. So remember this image. Now let's see the satellite picture. You see, most of the clouds are having over over this line. Now, what is causing this? So for to understand this, we have to go again back to the winds. And if we look at the again, let's go to the higher levels. Let's go to 400, for instance, because the height of the Tibetan plateau is around 5 kilometers. So we are above the Tibetan plateau height. So some our mountain ranges are there. So you see there is a blockages. So these are the mountain ranges which is beyond the 5 kilometer height. And these bends are actually are causing this drift of these streamlines to happen, because there are mountain ranging, and through these mountain ranges there are funnels. These mountain ranging behaving like a funnel, like funnels, and through these funnels or these openings, the winds are accelerating and creating streams of wind. Let's go a little bit more around. Let's go around 6 kilometers somewhere. Let's see how it looks. Let's yeah. So this is around 7 kilometer height. You can clearly see that these streams of clouds. And now compare this flow with the satellite image. You will clearly these two are matching, and that is why we are seeing the formation of these type of clouds, because of the wind pattern modified by the topography and mountains. This is all about the physics and what we are observing. Now let's look at what will be the better going to be in next 2-3 days. How whether this western disturbance will going to get weak, or whether it will remain, it will be, it may or may not be able to sustain, or what could be the status of its intensity. So for that we have to analyze the models. So let's see the rainfall and thunder from the ECMWF. So currently the colors are rainfall, and these stars are the snow. So snow and rain are happening along the foothills of Himalaya, where we are seeing most of the clouds, and also over the Punjab and scattered region of western UP and Delhi NCR and some part of MP, and some part of Rajasthan. Now, what we can expect in this is current level. Now, what we can expect in next, perhaps in night around 9 p.m. The intensity of rainfall likely to increase over the Punjab and some part of Haryana, maybe eastern or northern Haryana, and intensity of rainfall likely to remain high over the Uttarakhand, northern part of Uttarakhand. And what we can expect tomorrow morning? So let's see tomorrow morning. So this system likely to continue to move eastwards, and will along the way it will going to just vanish, because it will collide with the Himalayan ranges, and it will lose all its energy. So by 6 night, by 6 morning, it will lose its all intensity, and we will not see any signature. So this is the end of this western disturbance. What are the expectations? So only, I think, 12 to 24 hours are the maximum time window where this system will going to rain. Beyond that, maybe fog and maybe some low level clouds, nothing much after 6. So what we expect as in terms of accumulated rainfall. So let's analyze the ECMWF from let's see how much accumulation it will expecting for next 72 hours. So most of the rainfall accumulation remain as consistent with the satellite image of clouds. Most of the rainfall likely to remain confined to the Himachal, part of Punjab, of course, and parts of Uttarakhand. And if you look at the GFS, it is also expecting the similar but a little bit smooth because of its resolution. Uh, Unlike the ECMWF, which is expecting the scattered rainfall over the plains, GF is expecting almost no rainfall over the plains. If you look at the icon, again, it is consistent with the GFS, and it is having a quite a smooth pattern. Intense rainfall is starting from the Himachal, Jammu Kashmir, and Uttarakhand, northern Uttarakhand. So this is the expectations of rainfall, and yeah. So I think we are done with this western disturbance in next 72 hours, next 24 hours at minimum, and maybe 36-hour maximum. That's all for this western disturbance, and yeah, please do not forget to like, comment, share and subscribe. It motivates me to keep giving updates. And also, if you share and if you comment, YouTube algorithm suggest the video to other people who might be interested in such content. So it will also help other people to get prepared for such type of rainfall events. So thank you very much for watching and giving your time for this video. And I will see you in the next video. Till then, bye bye and take care.